Hello everyone. In previous video lecture we discussed inserting a node at beginning of the linked list. Now in this class we are discussing inserting a node at end of the linked list. It is possible to insert a node in three different ways to the linked list. It is possible to insert beginning of the linked list. It is possible to insert end of the linked list. It is possible to insert anywhere in the linked list. These are the three different algorithms we have for inserting a node to the linked list. In today, we are discussing inserting a node at end of the linked list. This inserting a node at end of the linked list, it consists of 7 different steps. Those are step 1 start, step 2 p equal to start. There are two different starts are there. It is actual start of the algorithm. Second one is the start pointer. Whatever the start pointer value contains, that I am assigning to a variable p. That is start. While p is not equal to null, p equal to next of p, end of file. It is a for loop is used to traverse in the linked list because I need to identify end of the linked list. How we need to identify end of the linked list? Just we need to be traversed through the algorithm, through the linked list until unless I am getting a null pointer value. When I am going to be getting null value, it means that I reached to an end of the linked list. For that we are having this while loop. Because in this algorithm we need to insert a node at the end of the linked list. If you want to insert at end of the linked list, so I need to be traversed within that linked list. For that we require this while. Once we reach to the end of the linked list, what I need to do is simply I need to create a node. For newly created node which contains two parts, data part, link part. For a data part I need to assign a certain value. For link part I need to add null value. Whichever the last successive node we visited, that address should be copied to the previous node. That is how we are inserting the node at the end of the linked list. The step 3 is n equal to new node, means I created a new node. Step 4, data of n equal to element. Whatever the new node which I created, which consists of two parts, data part, link part. Data part of that newly created node, to that I am assigning an element, means value. Step 5, link of n equal to null, because in linked list last node address pointer contains a null value. For that I inserted a node at the end of the linked list. That's why we need to add a null value to the last node's link pointer value. I am assigning null value to the newly created node for link part. Step 6, link of p equal to n. Means I created a node which created at a certain location, that address should be assigned to a link of p. While I traversing from beginning of the linked list, which is last successively visited, for that I need to assign n equal to link of p. Whatever the new node which I created, which is existing at a certain location, that address should be assigned to the previous node link part. Step 7 is written. It is how we are inserting the node at end of the linked list. Now we are going to discuss the same algorithm with help of this example. In this linked list, I created this linked list contains 3 nodes. Those are node 1, node 2, node 3 with an element 50, 40, 60. 3 elements are there, and these 3 nodes are located at memory location 100, 250, 123. These are the 3 respective locations where these 3 different nodes are created or existing. Now what I want to do is I want to insert a new node at end of the linked list. For given linked list I want to insert a node that should be inserted at end of the linked list. What I need to do is I need to traverse through this linked list so that I can reach to a linked list. Once I am going to be reaching to an end of the linked list, I need to create a node. Once I created a node, for that data part I need to insert a data element, it's a value. For link part I need to assign null value. For the last previous node which I listed, for this memory location I need to be assigned the new node which I created, that address should be assigned to this previous node link value. It is how we are going to be creating or inserting a node at the end of the linked list. Now we are going to trace out this with the help of this algorithm. First one, step 1 start, p equal to start. I am considering an value p equal to start. What is start pointer contains? Start pointer contains element 100, address 100, next file 100 is not equal to null. Yes, 100 is not equal to null. Condition become true. Once this condition become true, it enter into a loop. P equal to next of p. P equal to next of p, which is nothing but which is redirecting to the next node. Redirecting to the next node. Next of p means it is assigning memory address of the first node. Memory address of the next node element to an p. That is 250. 250 is assigned to p. 250 is assigned to p. Now p value is 250. P value is 250. Once again, 250 is not equal to null. Yes, condition become true. 250 is not equal to null. Enter into a loop which is listed the second node, which contains data part 40 and address part 123. P equal to next of p. P equal to next of p means I am assigning address of that second node, link part of the second node to a variable p. Now p is 1, 2, 3. Now p is 1, 2, 3. Once again it is repeating while loop. Now p value is 1, 2, 3. 1, 2, 3 is not equal to null. Yes, condition become true. Enter into a loop. P equal to next of p. Once it is visiting the last node, which is located at memory location 1, 2, 3, which consists of two part, data part, link part. Data part is 60. Now next of p, that is null value. Now next node 1, 2, 3, which contains value null. Null, which I am going to be assigned to a variable p. Now it is going to be repeating the while loop. Now null is not equal to null. Condition become false. Null is equal to null because we traverse the given linked list. Now I am at the end of the linked list. Once I reach to the end of the linked list, what I need to do? I need to stop traversing. At that end, I need to create a new node. Once I created a new node, for that I need to add a data part. For link part, I need to add a null value. And whatever the new node which I created at memory location, that should be assigned to a previous node. That's how we are inserting node at the linked list. Now we are reached at the end of the linked list. Now null is not equal to null. Condition become false. Once this condition become false, it come out from the loop. When it come out from the loop, what we are performing? We are performing n equal to new node and creating a new node. I created a new node n. Because I created a new node that contains two parts, data part, link part. Now step 4. Data is equal to element. It is the data part, it is link part. For the data of new node, I am adding an element 65. Add element 65. Next, link of n equal to null. For newly created node, for link path, what I need to do is I need to add a null value to that link path. Next, link of p equal to null. Link of p equal to n. Link of p equal to n is nothing but I created a node which might be created at certain memory location 144. I created a new node at memory location 114. This address should be assigned to its previous node. That is nothing but link of p. Link of p means I recently visited node 1 2 3. For that, what I need to do is I need to assign 144 to an lastly or previously visited node. It is how we are inserting a node at end of the linked list.